There we go. Okay, so I'm Nick Patch, and I have been working a lot with Unicode, various character encodings, and internationalization over the last few years, both working on projects to internationalize web applications, as well as detect and convert multiple different unknown character encodings to UTF-8. And through that, I've gained a lot of knowledge on Unicode, done a lot of wrangling, and I also realized that most people don't know enough about Unicode, which I didn't at one point, and I'd really like to sort of share some of what I've learned here. Right now, I'm actually working with Shutterstock on the international team, and as I'm sure you'll hear multiple times throughout the conference, we're hiring, so get in touch if you're interested. We're in New York City. Anyway, so what's a character? It is the smallest component of written language that has semantic value and refers to an abstract meaning or shape as opposed to a specific shape. At least that's what the Unicode consortium defines it as. And so for example, a glyph is a visual representation of characters, and fonts are collections of glyphs. There can be multiple different glyphs for any character. You know, you've got A in Times New Roman, A in Arial, bold, italic, and so forth. Those are all glyphs, and we're not here to talk about glyphs. We're talking about characters, which have individual meaning per character, as opposed to a universal glyph for them, since it can vary considerably and still mean the same thing to people. So let's just quickly go over some examples of characters. You know, you've got your letters, both in English and various other languages. You've got your numbers, punctuation, symbols. You know, there's some standard business symbols that people always consider as characters here. Then some things that are pushing it a little, like the pile of poo, which was released in Unicode 6.0, but really... Yes, that one. Although I don't know if it's defined with the stink lines or not. That might be part of the glyph. You could potentially include little flies. That would be part of the glyph. Anyway, the reason that's included as a character is because the Unicode consortium considers anything that you use in line with characters. So emoticons and such, you use them in line, flowing with your text. As opposed to justifying them with text around them. So they consider that to be a character as well. And also there are various control characters, which that's also sort of stretching it as far as the traditional sense of characters. But carriage return, no breaking space, combining grapheme joiner, right to left mark. We'll talk about some of these a little later. But some of these aren't really characters. They control how characters work. But for as far as Unicode goes, we'll consider these characters as well, even though some of them are non-printing or just affect the way that others print. I mean, even if you look at Morse code, they've got control characters as well. So there's a lot of confusion over the term character set. People use it to mean character code, character encoding, character repertoire, and there's good reason for the confusion, and that's because there's standards all over the place that use all different terms, and there's no unified usage of terms. I'll list some that I like to use consistently and make a lot of sense. Let's see, there's character code. Which is just a defined mapping of characters to numbers. Each value in a character code is called a code point. So here, the majority of the character codes that you'll use in computing actually have the same code points for A, B, and C, and the basic alphanumerics and much of ASCII. Yes? Yes, I will announce at the end where they'll be posted. So the code point for uppercase B, for example, is 42. Then a character encoding is an algorithm to convert code points to a digital form for ease of transmitting or storing data. So here I'm just showing the binary form of these code points. And there's nothing inherently attaching a code point as part of a character code to a character encoding. Then a character repertoire, it's a less technical term. It's just a defined set of supported characters. A lot of people say character set for this as well, just because it's a set of characters. But really, character repertoire is a good term for it because there are a lot of different things that have character repertoires. Character codes do, your keyboard does, natural languages each have their own character repertoire. So one character code and encoding that we know and love is ASCII. It is both a character code and a character encoding. That is, it has 128 code points, and then character encoding defined for all of those. It's 7 bits each, although in modern usage we take up 8 bits. But it only uses 7 of them, ignoring the high bit. Then there's the Latin 1, or ISO 8859-1 extension to ASCII that has 256 code points, doubling how many are available because you have the full 8 bits, including the high bit for use. And then there are a lot of other 8-bit encodings, ISO 8859-1 through 15. The reason we need multiple ones is because if you want to store each character in 8 bits and just have individually 8-bit per character, well, you can't store all of the world's languages characters out there, so you need to have one for various Eastern European languages, one for Thai, and so forth. And that is, unfortunately, you can't use 2 different encodings in the same document without some way of defining, okay, now I'm using this encoding, which people don't generally do. Like in email or web pages, you choose one encoding. That's why Unicode came around, because we're increasingly seeing a lot of multiple languages in international documents and such are just quotes from different languages, and you want to be able to use them all in individual documents, as well as have a variety of different support for working with text from different languages. So Unicode is a character code. It itself is not a character encoding. It defines over 1 million code points. Well, it has that many available. Defined, we only have a little over 110,000, but it grows with new releases as needed. 6.1 was released recently. 6.2 will be released later in the year, but that's only adding an individual character. Sometimes they're smaller releases, sometimes larger. So anyway, there are multiple encodings associated with Unicode. The 3 standard ones are UTF-8, UTF-16, and UTF-32. UTF-8 being a variable byte encoding, you don't have an individual length for every single code point. Instead, it ranges 1 through 4 bytes, so 1, 2, 3, or 4 bytes per character. This oftentimes can pack the most data into the smallest space, but it also is a little harder on computing because you can never just jump to a random point in a string and know what character you're at without scanning all of the data before it. Ingy?
Is it spec'd to go more than 4 bytes?
No, it's defined at that. Originally, it was defined up to 6. But when it was merged with the universal character set in the mid-90s, it was standardized at up to 4. So then UTF-16 is either 2 or 4 bytes. Yes?
So you said that you have to read everything.
Yeah, you would have to read everything before it.
It's not like you can read up to like 4 or 5 more bytes and then
You
don't know how many characters.
Yeah, you really have to count from the beginning.
Oh, for counting. Okay.
Yeah, counting's the issue, but on the other hand, UTF-8 is great because you can easily tell where the start of a character is.
That's a good point. If you did start somewhere in a string, based on the order of multi-byte characters, you know where the boundaries are. So you may not be able to count where you are, but at least you know that you're not corrupting data if you actually look at it. Then UTF-32 is consistently 4 bytes each. So UTF-8 is the most popular encoding around now. It has been since 2007. It is the standard and default for many internet protocols, and it's by default it's what I'd recommend using. UTF-32 really isn't seen publicly. It's more of something you see internally for when you do want that consistent 4 bytes per character. Of course, you need more space for that. So a code point. Here I represent for 3 different code points. First, a glyph representing that code point. Then the code point value, which in the Unicode standard is U plus the 4 or more digits. If it's less than 4, you pad it with zeros. And that's just a standard way to represent that character. And then there's a standard name. It's generally given in all caps, and it never changes. You can, if you're referring to a character, there are a lot of inconsistent ways that people refer to characters. Considering that Unicode is a standard that covers pretty much any character you're going to want to use, a great way to unambiguously refer to characters like in documents and such is by giving the Unicode name plus the Unicode code point in the U plus form, because that's standardized, and then you don't need a reference. This is a Unicode code point.
And that code point is always text.
Yes.
Oh, okay.
So there's a glitch. You want a little. That's not the code point for A. Code point for A is 41.
That's a very good point. Thank you. And please feel free to call out if you see any issues, because I want to make sure everyone's getting the most accurate information, and I can update the slides in the future if needed.
I had a little bit, wait, I thought A was 55, and it's 41 in text.
So some code points have precomposed diacritics. Diacritics being the squiggly characters and funny marks around characters. Like here we have Latin small letter O with diaresis, otherwise known as umlaut in German, and macron, which is the line above it. In this case, we have an individual code point 022B with the name Latin small letter O with diaresis and macron for this code point, but not in every case. So, for example, if you wanted N with diaresis, say you were spelling spinal tap, well, that's not in any of the world's languages. So the Unicode Consortium did not take spinal tap into favor when defining their character repertoire, and they came up with a solution for combining characters, where you have a base character, just a regular character, followed by 1 or more combining characters. There's actually no limit to it. And this is multiple code points, such as Latin small letter n, followed by combining diaresis, and it creates a grapheme cluster, an extended grapheme cluster. Commonly in the Perl world, you will hear this referred to simply as a grapheme. A lot of people Unicode folks have problems with that because it technically means something different, but you'll see grapheme everywhere in the Perl world to mean extended grapheme cluster.
Does plain graphene have a different meaning in Unicode?
It's slightly different, but they're along the same lines. But in the Perl world, there's no changing the fact that we use grapheme. If the term grapheme has a different meaning than extended grapheme cluster,
Originally, there was a legacy. There were other definitions before the extended grapheme cluster. Some of the old stuff might still be that. There's a legacy grapheme cluster.
right, extended grapheme cluster replaced the traditional grapheme cluster. So anyway, here we have an example of 3 different grapheme clusters. One of them is just a single code point. It's A, which I got right this time, right? Then the next one here is N followed by combining diaresis, followed by combining what's that called? Lower circle. I don't know the technical term. And another is actually CRLF, because that's really just a control character, even though it's 2 code points. Okay, so let's jump into some Perl.
This is where I gotta go.
See, Angie. So first off, let's just show how a few different ways to represent non-ASCII characters as Perl literal constants. Here we want to have jalapeno, so we're going with the traditional route of doing our escape sequence \x and then the hex value with optional braces if it's only a 2-character hex value. Then in Perl 5.12, it introduced a way where you can actually put the official Unicode code point syntax in there. It has a little more meaning than just a hex value there, but of course it's a little longer. So \N followed by the value in braces.
Didn't something like that exist in older versions of Perl, maybe using a module, char names or something?
Well, I'm getting into char names now. And if you use the char names module, here we're using the full flag so we can use the full Unicode names. And now with \N, we can pass the Unicode names. Yeah, it's a lot longer, but it really tells whoever's using the code in the future exactly what it is without having to look it up. And then, if you use UTF-8, you can just put your UTF-8 data directly in your file. And this is also a nice solution when, see, with jalapeno, I mean, we know what that is, the N with the enye and the upside down bang. That can oftentimes tell the most at first glance. But there are other times when, say, you might have combining code points that you can't see visually, and you want to emphasize the fact that this is a separate code point. And in your pod, if you're going to use non-ASCII characters in UTF-8, you just say encoding UTF-8 at the top of your pod. Yes?
On the last slide, you actually don't have to use UTF-8 because that's just a bytecode. That's buggy.
Well,
But you don't have to.
I'm telling you, you have to. If I'm reviewing your code, I'm saying you have to.
You do, because otherwise it's interpreted as Latin 1.
Yeah, I mean, because the thing is that we're going to get into the Unicode bug a little later, but it's ambiguous here. Is this Latin 1? Is this UTF-8? Traditionally in Perl, it would be Latin 1.
First example, traditionally in Perl, that those three lines would be expressed in Latin
By default.
by default. And then when it's run, when you do that say, as long as your output device is capable of what?
So what we're saying here is that our source code is encoded as UTF-8. Say you're
He's confusing the first and second example.
No,
First
no, no,
example is Unicode.
I got that, but so right, and you're saying, but sorry, so when it does the say though, and it outputs it to journal?
yeah, we'll get into that.
Oh, sorry.
What's happening is the Perl interpreter defaults to interpreting as Latin 1, and it changes to interpret as UTF-8 if it sees it right.
Right. So, for example, all the examples that I showed up until this could be in ASCII. Well, it could even be in any encoding that supports the ASCII subset. But once we get into this last example on this slide, we are saying that our source code is in UTF-8, as well as this pod. So, in general, the flow of your application, assuming that you have UTF-8 input and UTF-8 output, is you have your UTF-8 encoded input, you decode it to a Perl internal string, which is a Unicode string, you encode it, and then you output UTF-8 encoded output. Of course, you may have some different input or output. Just replace whatever your encoding is for your input and desired output here. But this is the general flow, is that you decode on input, you encode on output. So when we're opening, yes?
In general, what Perl versions are you referring to?
I'm trying to point out if it differs by version. It's hard because in some cases, because there's been a lot of progress in Unicode and UTF-8 support over like every version 5.8 and since. And I recommend using Perl 5.12 or greater if possible. But oftentimes we're stuck with 5.8 in many situations, depending on our work environment or server environment and such. So I'm not keeping this talk to any specific version of Perl and trying to point out where it differs. So when we're opening a file handle for reading here, using the less than sign for reading input, if you put colon encoding and then specify what encoding, it can be anything you want, but I'm using UTF-8 for all of our examples. You will decode all of your input from that file handle. And for output, you do the same thing. You can optionally add even like spaces between your specifying the input or the read or write mode and that colon there if you want it to be more readable.
Does this work in 5.8 or do you need bin mode for that?
This works in 5.8. But here's bin mode. If you already have a file handle open, so say you're working with code where you can't go and change the initial opening of that file handle, you can call bin mode on it, passing your file handle as the first argument, and then doing the same colon encoding syntax for the second argument as a string. And then for any of the standard in, standard out, standard error, you can do the same thing. Now, you can specify at the top of your file to open all file handles using UTF-8. So in this example, we're using the open pragma and specifying that our input and output of our file handles is going to be in UTF-8. And it will just do the implicit decoding and encoding for us. This example here does not handle standard in, standard out, and standard error, because this is how you do it. Also pass the standard flag, and it will handle those file handles as well. And there's a CPAN module, UTF-8 all, which will do quite a bit behind the scenes for you. It's doing the use open encoding UTF-8 standard, and also use UTF-8 to specify that your source code is in UTF-8, and some other things as well. It's handy, but you should make sure to read the documentation and know what it's doing first, because it's not, there is no one-shot solution for everything. I use it a lot on one-liners as well, just because it's a simple way for me not to do all sorts of like dash uppercase M on my one-liners. Then for those cases where there's a lot of times where our input and output is not via file handles. So you can explicitly decode and encode your values by using the encode module. And you've got your decode and encode functions where the first value is the name of your encoding, UTF-8 in our example. A little later on, we'll get into the differences between UTF-8 and UTF-8 for those wondering. And there are a lot of different frameworks we're working with, Catalyst, CGI, and so forth. Many of them provide options for their own implicit encoding and decoding. Say, for example, parameters passed on through URLs and such, but you'll have to reference the documentation for those. So one issue that comes up is string length, because you can't just use the traditional length for every purpose here. In the next few examples, we're going to use a string that is just the grapheme cluster Cyrillic small letter U followed by combining acute accent. There is no pre-composed code point for this, but it's commonly used in Russian dictionaries to show the emphasis on the Cyrillic small letter U. So say we have this grapheme cluster encoded as UTF-8, and we pass it to length. Well, we're going to receive 4 back, because those two code points are double byte encoded in UTF-8. Now let's decode that from UTF-8 to a Perl internal string and pass it to length. Well, now we're getting 2 because we're calling it on a Unicode string as opposed to just an encoded series of bytes. Well, what if you want to look at this on what the user considers a character? Because when a user looks at a word that has combining code points, they won't consider it multiple characters. They'll consider it one character. So if we want to count that as an individual character, well, let's see how we do that on one line like we're doing these others on one line. It gets a little more complicated here, but it gives us 1. Let's take a look at that a little closer. There is the \uppercase X regex character, and it has been around for a while now. I think since Perl 5.8 actually, but it has sort of improved a lot over several releases. And unfortunately, up until I think Perl 5.12, you won't get consistent results with it, but it's a very good character to know about because it matches individual grapheme clusters. And here we're using, I forgot I've got a laser pointer on this thing. We're using the G mode to globally search and putting it in list context and then back into scalar context. And it's a little messy, not very readable here, but we are getting are counting that we have one grapheme cluster. So let's look at another way. It also gets tricky because what if you then put it into list context, like you want to print or say that out, you'd have to explicitly put it in scalar context. So I wouldn't recommend doing it like that. Here's a little better way. You know, it's more readable. Really just looping through this regex and counting each iteration, and then you can use your incremented number. There are some other ways that aren't part of core Perl. Here we've got use Unicode GC string, which is Unicode GC string is a very nice module. It stands for grapheme cluster string. And here we are instantiating a new object, passing our string to it. Now remember that this should be a Perl internal string. This shouldn't be an encoded series of bytes. Generally, we want to be working on our Perl internal string throughout our body of code because we decode on input, encode on output. Everything we're doing within our code base that's in between that is on Perl internal strings. And then we're calling the length method and getting 1 back for this example we've been working on. Here's another module. It's Unicode util, and a warning. It's my module. So it's still a work in progress, but I use it a lot. And it provides the graph length function. So, any questions on the topic so far? Rick? So, which one are you? So, 0 width characters, as far as graphing clusters go. Yep. I think well, length count.
It doesn't care if it's invisible. It depends on how. I think there are some funny things that are invisible that do code are invisible. Function, map operators. Are you going to give to the columns method?
No, I'm not in this talk because there's so much that we can talk about Unicode. We could have a Unicode conference. In fact, there is one. It's 3 days as well. And Tom Christensen is going to be giving a Unicode regexes talk tomorrow. I think that's 2 hours. So double the time, more than double the time than I have, and it's just for regexes. I'm looking forward to it. I hope to see many of you there. So I'm not going to go deep into regexes because he's covering that.
Pretty related. How about languages that are static? Stable modules, alpine over. The characters that become event, are they considered one grapheme or not?
One of the reasons they had to be combined with because they are integrated with
So for those who can't hear, the discussion is about various Eastern and non-Latin based languages that do various forms of character stacking, and we'd really have to go in a case-by-case basis to look at it, but generally these are individual graphemes when you combine characters together that are stacked on top of each other or have diacritics on, under, or either side of them. So let's get into collation. So collation is a standard ordering of strings for comparison and sorting. So there are a lot of different collation standards out there. Uses of collation are, sorting, your various comparison operators like compare, greater than, less than, string equals. Now in Perl, its built-in collation is just based on code points, which means very little in a natural language point of view, because code points aren't ordered in any way other than with A to Z in order, but they aren't ordered in any way to do with natural language. It's just, here, we need more characters, we'll assign them another code point. The only thing with Perl's default collation, the only thing it's really good for is having a standard sort order that will be the same every time. But say we've got these words here. We've got apfel with or A with diaresis. Say we use the default Perl sort for this. We're not going to get an order that would be very useful here. In fact, we provided it in our ideal order to start out with, and it just reversed it for us, essentially. And that's because, in this example, we're not taking case into consideration. So considering that different cases are different code points, we have our uppercase first, then our lowercase, and then our various non-ASCII characters. Yes?
I guess you're getting to normal forms at some
Yes.
point. So I think that would also affect the answer, how Perl parses it.
Yeah, so we'll get into normal forms next. Now, the traditional Perl way of dealing with this is to pass a block to sort, and then take your value A and value B in either lowercase or uppercase, both of them. Well, that helps out a little bit. At least Xerxes doesn't come after durian in our example, but still that doesn't help out with our non-ASCII characters here. And even when we're just talking about ASCII characters, it doesn't necessarily make sense as far as where the various punctuation and such is organized. Now, I'd like to point out that Perl 5.16 has a new FC function for fold case, as well as if you don't have the privilege of using 5.16, which I imagine very few of us do at work, there's the Unicode fold case module in CPAN that will provide the function for you. Anyway, I'd say from this point forward, it is the preferred way to do this last example. Instead of LC or FC, use FC, because there are characters like the German sharp S that, when capitalized, are uppercase S, and that doesn't represent very well for comparison. So FC will handle that well. So anyway, let's get into the Unicode collation algorithm, which is part of the Unicode standard, and it is a very smart way of providing collation based on the world's languages. So my slides got mixed up. Okay, so sorry, there's an error on this slide. Ignore : locale on the slide. So anyway, if you use the Unicode collate module, instantiate your collator, it provides a variety of methods based on the Perl core functions, but we'll use the Unicode collation algorithm. So here we're calling the sort method and passing a list to it, and we get a result that we'd like here, with the A with diaresis coming first. And it has methods for all of the examples I showed earlier, as well as the ones that I haven't showed that are included in Perl core. Here, sort, compare, string greater than, string equality. Because sometimes the collation values for comparing two characters that are two different code points can be equals. Now, the UCA, although it has a default collation algorithm, which is I'd say the default one you should use if you don't know what to do otherwise. It's very smart, and if you've got mixed data from multiple different languages, really that's the way to go. Now, if you're using it, take a look at the Perl doc, because there are a lot of options to send to it. It's highly configurable. So LC is Unicode aware, but it is not good for comparison when you're taking two strings to compare. Case folding provided by FC is the ideal way to go. So say we want a Polish collation, which the default UCA algorithm isn't going to provide collation for every single language exactly how they do in the country that uses that language. So if you use Unicode collate locale, really using double colon locale this time, and provide either the two-digit language code or a locale based on the language code underscore country code, if it's one of the available locales, it will provide collation tailored specifically to that language or that language at that country. And
Should we need locale in the second one or not?
Yes, that's a very good point. Unicode collate locale and then Unicode collate locale new. Now we'll get into normalization. Yes?
What about the case where dictionary order is different from other
Right. So German's a good example there because the dictionary ordering of German is different than the phone book ordering of German. So with the diaresis, or we can call it umlaut here because we actually are talking about German, with the, say, O umlaut, that is generally considered to be equivalent to OE and should be collated as if it was OE. But it differs in phone book usage. So there's actually a DE for German, underscore phone book locale. And there are several specialized ones available with the UCA. So Unicode provides 4 normalization forms. The most important ones to know about are NFD, which is normalization form canonical decomposition. And I apologize, it's a mouthful. I'll just refer to NFD. Then there's NFC, normalization form canonical composition. So the reason we have these normalization forms is because I mentioned how you can have combining code points. Say you had your precomposed code point for A with diaresis. You could also have A followed by combining diaresis, and we would want to consider those to be the same thing. As far as collation goes, comparison, that should be the same thing. Well, normalization will put them in the same form consistently. You could also have a series of combining code points, and some of them may not compose onto, may not have pre-composed forms onto your base character, but you want them to be in a consistent order. Well, normalization is the way to go. So NFD for decomposition will make it in, break it out into the longest form possible. So if you have your pre-composed A with diaresis, it will break that up into 2 code points, A followed by combining diaresis. Whereas the NFC, canonical composition, will first run NFD. It will decompose it into your standard decomposed form, and then it will recompose it.
So NFC is the shortest form possible?
Yes, NFC is the shortest, NFD is longest, but NFD is always run in order to get to NFC. So NFD can be helpful on input. Generally, just standardizing on input is a good idea. There isn't any one where this is what you need to use. It's all on a case-by-case basis, but NFD can be helpful on input because then, say, you could use a regex, match a regex against your string where you want to, say, find O followed by O in any of its forms. Well, then when you have your decomposed string, you will always have your individual code point for O followed by your combining code points. So you could do a positive look ahead for O in your regex followed by, say, \uppercase X. And that will match any grapheme cluster that is based on O. If you don't need to do stuff like that, feel free to use NFC on input. Now for output, NFC is especially recommended. There are various protocols that recommend that you use NFC on output. Reasons are, 1, it takes up less space, but 2, it has the best support in applications. You want to make sure your web browsers and email clients and such can support the characters. And, well, most applications don't have full Unicode support or even very much of the Unicode support that was introduced in the last decade. So your best bet for working along on many different devices and browsers is to output composed. This is still done on your Perl internal string. So any NFD, NFC, any normalization you're doing after you decode, before you encode. Here is the order. So UTF-8 encoded input, decode it, normalize it, then you're working with your Perl code, normalize it in the form you want to output, encode it, and then you've got your UTF-8 encoded output. Not everyone needs to work with normalization, but when you do, it can be very useful for the cases that I said. Yes?
Can that NFC be attached, or can that NFC be attached as one of those options for file?
I've thought about that, and I haven't seen anything like that, but it's a great idea for a module. So it's if you can do a mode for opening a file handle where you automatically normalize. And I haven't seen anything that does that. I haven't seen any modules that do that. I've thought about it. I think it's a great idea if anyone wants to work on that.
Maybe one reason it isn't built in is that normalization is way more complicated than encoding or decoding.
Yeah, it'd be nice to have an option, even if it's not necessarily built in, but a CPAN module. So anyway, I'm gonna finish up my slides because we're running out of time here, and then get on to questions. I only have a few slides left, by the way. Unicode semantics. By default, unfortunately, Strings and regexes are not guaranteed to use Unicode semantics, and that's because traditionally Latin 1 was the default, not UTF-8. And this is known as the Unicode bug because you can have inconsistent results. There are a few ways to fix that. One of them is calling UTF-8 upgrade. You can call it multiple times, and it's not going to do multiple upgrades that will break your data, but it will make sure that your Perl internal string is using Unicode semantics. So, for example, when you've got Unicode semantics, \W will treat it as Unicode, and it won't just match ASCII, it will match all Unicode alphanumerics as well. Unicode digits for \D, that might not be what you want, so you might want to be more explicit and use a character class 0 through 9. When you use Perl 5.12, that will make sure that all of your strings are using Unicode semantics. And the feature, from the feature pragma, Unicode strings is provided as of 5.12. If you don't want to use all the features of 5.12, but you can only use this 5.12 and later. Then I mentioned I was going to get into uppercase UTF-8 versus the lowercase UTF-8 without a dash. This is a confusing issue. You see a lot of people using both of these, but they're different. Both of them are implementations of UTF-8. The lowercase UTF-8 without a dash is very lenient. It will allow errors in your UTF-8 data where you will have incorrect Unicode data in your Perl internal string, whereas uppercase UTF-8 is a strict interpretation of UTF-8, and it will not allow invalid Unicode data. Instead, it will warn, and it will replace that with valid placeholders. Just beware that it will change your data when you encode. When you decode and then encode using uppercase UTF-8, and you have invalid data. It will change it, and you won't have the same output in the end. I generally recommend uppercase UTF-8, though, and that's what I use. Yes? What's that? Oh, this is a Perl thing. This is just for encoding and decoding in Perl. Anywhere that you would list your encoding, whether it's at the top of your pod or anywhere. Not use, because lowercase UTF-8, and there are a lot of confusion here. Lowercase UTF-8 pragma is a named pragma. Feel free to use that. Use UTF-8, all lowercase, no dashes. That's fine. That's a named pragma.
Is there a way to control how strictly Perl treats Perl source code? Or does it do the more lax version?
I'm not sure about that. So the question is there a way to specify if your Perl source code is treated as if it was, uppercase UTF-8 or lowercase UTF-8? I imagine it's lowercase UTF-8, but yeah. But you could have it in a string.
Oh yeah.
In a constant. So anyway, anywhere that here are examples of where you could use either form.
If you want strict UTF-8 for your source code, I've done use UTF-8 and then use warnings fatal to UTF-8. Then you'll get a compiler error.
Yeah, that's a good point. You can change how your strict UTF-8 works. So instead of doing warnings, you can specify that it's fatal, or there are other ways that you can specify what it's replaced with. But that's a little more than we have time for here. I'm going to post the slides on Twitter and on my website. Any questions? Excellent. Yeah, I'll be here for the rest of the week, so feel free to come and find me with any questions. Do you have something?
Well, just a comment about when you use that NFC and NFD. That's an example where the save your UTF-8 other fragment you had.
Unicode collate or Unicode GC string?
No, there was some use like UTF-8 all or something. Whatever.
Yeah, UTF-8 all.
That would be an example where you think it's helping you, but that kind of stuff is still in. You need to know Unicode.
Yeah. Okay, well, thanks, everyone.
I'd say this is one of the more useful talks I've seen today.
Thank you.
Partly because a lot of these things are actually things I wanted to know and deal with. Go ahead.
You had mentioned something about you were working with documents in unknown encodings. Now, when you said unknown, did you mean that you weren't able to identify them before you got them, or once you read them?
Right, I had to detect them.
You did detect them. Okay.
I
Once you detected them, were they mostly well formed enough for you to be able to work with?
It wasn't always correct. It was working with massive amounts of data over 20 different character encodings. Some of them with very small amounts of data because it's just individual fields in a database. Where then we had to use aggregate data, where we say use say all of the fields in this row and try to detect based on that. So I'd build tools looking at heuristics and using other tools.
Probabilistic decoding.
That's a great example of the word heuristic.
Yeah.
Okay, great. And have you read Joel Spolsky's article on?
Yeah.
Yeah. Okay.
It's a good starting point.
It's a good starting point. Okay. Yeah.
Yeah, that's what I tend to hand people. Just like, here, you want to start off? Here, read this.
That's I actually mentioned that too. Thank you so much.
Thank you.
Talk.
Yes, I want to say the same thing. This was great. I wasn't sure whether this was the right talk for me to come to because I already know the basics of Unicode. I know what a code point and a code page, and I know what UTF-8 is. But I learned a lot today that I didn't know. So you